and a very good afternoon to you all. This is Erfan Ibrahim of the Smart Grid Educational Series, and I am very pleased to have all of you join today as we hear a presentation from Mike Bourton on the migration strategies from Smart Energy Profile 1.x to Smart Energy Profile 2.0. As many of you know that the movement from 1.x to 2.0, the big thing that happened was that this application is becoming more and more platform independent. So you have a variety of protocols that can now support it, including things like Wi-Fi and home plug, and also the 802.15.4. And this brings a big innovation in this field for customer premises integration into the grid. We've been talking for a while about the need for demand response, not just for clipping the peak in the afternoon, but also as a way of helping shape the demand for electricity so that it is more in line with the availability of renewable energy. As you know, in the last 12 months, about half of the new capacity that was brought online in the U.S. came from renewable energy, in which solar and wind plays a big role. These sources of energy are not available at all times, and they may have intermittent aspects to them. So the supply of electricity, the cumulative supply of electricity on the grid, can start varying based on the availability of renewable energy as the energy mix becomes more and more in favor of renewable energy. Why is this important? Because if we want to avoid brownouts and blackouts in the future, because we don't have the reserve spin to absorb the intermittency of renewable energy, and storage is still expensive in large amounts, we will have to shape the consumption of electricity so that it kind of follows along the way the cumulative supply of electricity is available. Otherwise, we will have to pay premium prices for that additional kilowatt hours of electricity. Now let's think, if that's the case, who needs to participate? Well, industrial and commercial sectors have been participating for a while now, and that's about 2/3 of our energy consumption. But the final frontier that was left was the residential sector. The key difference in residential sector is that you don't have a facilities manager sitting at every house that is knowledgeable on what to do and how soon to do it. So the answer was automation. We need to have the ability to get signals to a customer prem, whether through the AMI network or through the internet, to a decision-making device in the house. And then based on policies that are set, that a customer is willing to accept a certain price for a certain device to work, certain things will come on and off based on that policy. Well, that's very nice from a business perspective, but how do you accomplish that? You accomplish that by having devices that follow open standards, so that it doesn't matter where you buy them from and where you place them, but those standard protocols and the semantic layer, or the common language, needs to be there that understands the granular attributes of devices to control, so that the coordinator can be from one vendor and the smart appliances can be from another vendor. We were not there a few years ago when we had highly proprietary protocols working in home area networks, using network protocols that were also locked down, vertically locked down, so that the semantic layer and the protocol in between and the FIMAC layer were all kind of cobbled together. It works great if you have a single vendor solution, but when in the smart grid, what we're talking about going forward is a multi-vendor environment. So in that environment, it's really important to have open standards, not just in the semantic layer, but all the layers, so that they can be very modular in the architecture and can fit in. If this happens, then in the future we will have mass penetration of smart appliances. And if we have mass penetration of smart appliances that can turn on and off based on consumption, based on how much electricity is available, then we can start thinking about shaping the demand for electricity along renewable energy and allow for greater penetration of renewable energy on the grid without it going unstable. Because key thing is, how do we maintain 5 nines of reliability in this new paradigm? And it's not that simple. Now we are getting into nonlinear control theory, we're getting into storage, and we're getting into areas where a new kind of engineering and science needs to be introduced. But one thing that can really help this whole picture is customers getting more involved. And customers getting more involved through this technological innovation with smart appliances is key. And today's presentation is about one step in that direction. By having an IP-based protocol that separates the underlying technology from the upper layers, and by creating a model that can easily port over Wi-Fi, home plug, ZigBee, and hopefully in the future Z-Wave and others, the hope is that it will become like a commodity. And once it becomes a commodity, we go from it being an invention to an innovation, and we can start enjoying the fruits. So with that background, I wanted to give you this motivation because there's a macroeconomic reason why we absolutely need to do this. And that's why I said it's a must-see presentation, and Mike Bourton will not disappoint you in any way. He has thought about these things for years. He believed in it so much, he put a company together with the help of Don Sturek that's well-funded and has actually created firmware that is now being tested in a variety of pilots across the world, not just the United States. So we're very proud to have such an innovator amongst our midst, and we welcome him. So, Mike?
Do you want to do a sound check to see if everybody online can hear us? Because we haven't checked that, have we?
Yes, so let's see some comments if you can hear us in sound, if everything is good, and then we will continue. So just put a note in the chat window. Can hear great.
Thanks.
Very good. Good sound. All right, thank you very much. And we will now continue with our presentation. So Mike, take it from here.
Okay, thanks everybody. Normally Erfan's presentations can go on for the East Coasters till late at night, so hopefully you can all stay awake for this one today. I'm going to talk about SEP1 to SEP2 migration, and I'll just give you a little quick overview about what SEP1 and SEP2 is very quickly, so that people know what we're at least talking about. SEP2 I'm not going to go into too much. In fact, a month ago or so ago, I gave one on, and if you dig through the files of Erfan's recordings, you'll find a little talk from me on the whole subject of SEP2, but we'll cover that as an overview. So, oh, how do we go down?
Page down.
Page down.
Yeah, you have to click on the previous.
Oh,
So we have to go here, do that.
okay, we've got control now. So, as I said, going to give you an overview of SEP1, SEP2, and I think it's important to state a few things we learned. The learning process, of course, is always better the second time around. So there were many improvements made on SEP2, but thanks to the people that put a lot of effort into SEP1, we had that learning experience. I'm then going to discuss why to upgrade and some of the strategies. And before I take any credit for a lot of this stuff was created in a PAP under NIST, SGI P1.0, called PAP 18. And I've got a link in here, and Erfan, when he sends it out, the link will work hopefully, and so you can have a look at all of that. There was an interesting white paper on that subject. And then I'll give you a quick summary of what I've discussed. So this is the block diagram for step one. It's very hard to see in sort of a 7-layer structure, but basically there's a physical layer, a MAC layer at the bottom, two sections. There's a networking layer, there's an application support layer, and then there's the application framework at the top with the ZigBee cluster libraries. It's very difficult to see how this aligns with an IP structure because it's really not an IP base, but if you like to say the MAC layer and the PHY layer, the layer 1 and 2, the network layers are 3 and 4, the support layers are 4 and 5 and 6, and the application at the top, the application layer is a layer 7 if you try to draw it as a 7-layer structure. So here's a quick description of those layers that I've talked about. So the MAC PHY that was chosen for ZigBee is the 802.15.4 2003. At the time, they didn't use the MAC security that later became in the 802.15.4 2006 layer. It operates in a beaconless mode and at 2.4 gigahertz. The network layer is a binary protocol. It's not IP, but there is a mesh routing for, that's based on an IETF spec called AODV with a few ZigBee modifications. The application support layer is there's a special ZigBee frame structure. There's an optional guaranteed delivery feature, an optional fragmentation protocol. The security of that layer is an AES 128, and it supports 255 sort of endpoints or clients when we talk in the SEP2 language. And the security, there's no MAC security, but there is a network security, there's an application security layer, and there is a network key with an installation, a 48-bit key, 4-bit field key for installation code. The application objects are a ZigBee cluster library, and if you're familiar with the ZigBee home automation, it's a form of, the SEP1 is a form of that cluster library. And it defines a set of command responses and attributes. That's a very basic description of ZigBee Pro. Then the SEP2, which was developed under ZigBee, but as later was required in the MRD was to support over any physical layer, is basically a very structured IP sort of layer, structured. There is the MAC PHY as before. There's the IPv, we used IPv6, TCP, and UDP. And then there's a support application layer and then an end user application layer. It uses HTTP and XML or EXI if you want to compress the XML. And then there's the security that bridges across all the functionality, including the MAC layer. So here, so the description of this block diagram is all the blocks in the SEP2 are standards compliant. Comes from IETF, IEEE, W3C, etc. The MAC PHY will run over any MAC PHY, as Erfan said. Examples are Wi-Fi home plug 802.15.4 using ZigBee IP that was developed under ZigBee. The transport layers are IPv6 with TCP and UDP. ZigBee, that is a smaller frame structure than what typically is an IPv6, uses 6 low pan and has its own role mesh layer, routing layer. All the layers must be certified to get SEP2 approval, so the MAC PHY must be approved, the transport networking layer, the ZigBee layer has to be approved, and the application layer, which is really what SEP2 is really defined as the application layer. The security, the MAC is AES 128, network layers TLS, application uses elliptic curve cryptography encoding, so we encrypt the packets. The application support layers all standards compliant. It's HTTP or TTPS for the data exchange. It uses a protocol called MDNS or XMDS, which was extended for the use of this application, and DNSSD, and that you probably know that is language of Apple Bonjour, and it's used for the zero configuration, so that you can configure this without any configuration by the consumer. As I said, it uses XML for the payload, and it can be compressed if you want to have sort of short transmission bursts using EXI. Smartphones and tablets are supported over Wi-Fi, for example, in this method. The function sets are derived from the 619868 60 SIM. This is what's used in the back office by the utilities. So it's actually it's very aligned with their SIM. And of course, we package that as XML over HTTP or TPS. It's a very basic description, but this is not what our talk is about, really. It's how do we migrate between these two protocols. Now, SEP1 has been deployed in most of the meters that have been shipped in the US. So in many cases, we've got the choice of either upgrading those meters to SEP2 or finding a way of translating the SEP1 meters into SEP2 for the home area network devices. So let's look at the lessons learned, and then we'll see how we migrate. So on the security layer, the SEP1 had no MAC security, and it's actually prone to certain types of replay attacks. I won't go to what the security hole is because that's would encourage people to go and hack it, but it does have no MAC layer security. And the application layer key used is a bit short. It's 80 bits long, and today the recommendation from NIST, for instance, is at least 228 bits. 80 bits is a very short key length. There was a lot of delays due to a lack of interoperability in SEP1, mainly because interoperability was performed post when the devices were shipped into the field. And I know a lot of field problems with delays were caused when the field trials come because they didn't get interoperability. And SEP2 has spent a lot of time in interoperability testing during the specification. And there really wasn't a really comprehensive certification and test program for ZigBee Pro. A lot of it was done in the field, and independently by some vendors actually, which got together and tried to sort those things out. Another lesson that was learned, I guess, is that just using one physical layer actually is a disadvantage in that some cases you need to get other physical layers for other reasons. For instance, Wi-Fi is great for coverage. PLC is great for range, and for instance, on the MDU applications, the multi-dwelling unit applications, which is why PLC was considered for the utilities and why it was brought in for the SEP2, is to get the range between the meter and the apartment maybe a considerable distance, and you can't do that normally wirelessly. ZigBee, though, still has its purposes, and it's actually very good for low power. And of course, Ethernet gets us to the internet, and wherever you can plug an Ethernet into something, you actually can get a lot of coverage by then going through lots of devices. Another thing that they wanted to see in lessons learned was that all the components should be sourced from international standards bodies. That way, when you put these lots of pieces together, because involved in putting a product together is a considerable number of different pieces, you end up with something that somebody can put together. And when you have an international spec, they're very well defined between the boundaries too. One of the disadvantages that was identified in the first SEP1 was the single source components, in which case, in this case, there was a Certicom certificate that was a single sourced, and it gave a few problems there. There was also a lot of issues with the IPR agreements, with the way it was developed inside of the ZigBee Alliance, and really didn't require people to define their their rights during the spec development, and it was only discovered after it was shipped to the field. Scalability was an issue, and that was addressed with IPv6. And aligning the hand with the utility back office proved to be one of the things that SEP2 brought along, which will give an introduction, will help with the integration of back office systems with home areas. And then one of the things that was insisted on was deploying industrial best practices. And in fact, SEP2 has got a lot of credit from a lot of the PAPs that worked in NIST for the way that the standard was put together in SEP2. So a couple of the SEP2 benefits that come out of this was there's a lot of additional features have been added to the SEP1 features, for instance, for plug-in vehicles using something called flow reservation, distributed energy resources control, solar and wind energies, support for concurrent and multiple MACs, PHYs, meaning different Wi-Fi, home plug, ZigBee, Ethernet, alignment with the SIM, which we discussed. Security has been vastly improved. There's now 3 layers of security in the system. And also going standards-based internet protocols allows you to use devices that we commonly use today to actually interface and get information, such as your computer, your tablets, your smartphones in your pocket. So, as I talked at the beginning, there was a team put together called PAP18 that looked at this SEP migration. And it was formed in SGIP, and it was actually to formulate the answer, how do we migrate from SEP1 to SEP2? So nothing I'm showing you here is really something that, individually is being come up from Grid to Home. This is being developed by a group of individuals in the PAP, but representative from all stakeholders were involved in this, from the utilities, from vendors. The issue that had to be dealt with is when you move from a non-IP to an IP version, you end up with no backward compatibility. You cannot get compatibility between SEP1 and SEP2, neither at the network or the application layer, and nor in the security architecture at all. And today, a lot of meters were deployed with SEP1 that may not be able to be upgraded due to the memory constraints that they have on fitting this new protocol. And you'll find if you click on that link, it'll link you straight to that PAP workspace on the SGIP 1.0 work site, and you can actually pull down the paper if you wish on this whole subject. So PAP18 brought the concept of what's called an ALG. An ALG is known as an application layer gateway. It's the only way you can translate two forms of incompatible protocols is at the data level. That's known as the application level. And the reason why we came up with this method is because it's the only solution that there's out there if you can't upgrade your meters from SEP1 to SEP2. You need to translate the data between SEP1 and SEP2, and the only place you can do it is at the data level, at the very top level of the stack, the application. So some existing smart meters don't have the physical resources needed, and the physical resources we're talking about is the memory. They can't be upgraded to it, and the ALG enables, with some limitations, to enable support SEP2 hand devices using SEP1 meters. Some meters may be partially upgradable to SEP2, and you can do that because if you put less of the functionality of SEP2 into a meter, you then can do partially, you can support some functionality, but you may not be able to support all of it. Example is you may be able to partially upgrade and just provide demand response signals. But then you might not be able to support the functionality for electric vehicles which need to make reservations for power. And there are, of course, and I'm not really going to show any slide on this, but you can upgrade some of these meters to SEP2. So the migration path is easy. You just send down a new software code to the meter, and you instantly got a SEP2. Now that will give you a problem if you've deployed SEP1 hand devices, and now suddenly you don't have the interface to be SEP2. And so that gives a whole set of issues too, and you may need what's called a reverse ALG. In other words, you may have to convert from SEP2 to SEP1 instead of the forward, what's known as a forward ALG. So we're going to go through some of these strategies. So the set of use cases here that basically came out of PAP18. First use case was simple. We've already got we've got a ZigBee SE1X only HAN. Use case 2 was we've got a SEP2 only HAN. Okay. Use case 3, we've got mixture of devices, and those where your use cases are. And you want to go from those 3 use cases, and you want to be able to create some of the bottom ones. So using the ALGs, you can actually, what we call a category 1 is full function meter plus an ALG. In other words, you have a SEP1 meter, keep it a SEP1 meter, don't upgrade the meter, and then you need an ALG, and then you can add SEP2 devices into the HAN. A limited functionality category 2 is when you limitedly upgrade SEP2, but then you might need a reverse ALG because then you've got to have devices that may be SEP1 HAN. Now, fortunately, most states haven't shipped a lot of SEP1. Texas is an example where SEP1 HAN, and in California we're starting to ship SEP1 devices today. But that's about all in the country so far. So there's 2 types of ALGs that have to be considered. One, I've described already, forward ALG. It actually enables SEP2 HAN devices to work on an existing SEP1 meter. and also SEP2 devices with limited SEP2 meters. They will both be requiring a forward ALG. A reverse ALG is the opposite. We upgrade the meter to SEP2, and then we need to support the hand devices that was SEP1 there. So let's look through these scenarios, what they look like. So here's really a block diagram of what a ALG would look like. On the left-hand side, you've got basically a SE1 protocol running over an 802.15.4 PHY. On the right-hand side, you can have a mixture of interfaces between 802.15.4, Ethernet, a Wi-Fi, and a PLC, and they all work on a single SEP2 stack. It's a TCP-based stack using HTTP. At the very top layer, you'll see there's something called an application layer gateway functionality. That is where the block where you convert data, not protocol, you actually exchange data at that top level, enable you to go up left-hand side and come down the right-hand side, or go up the right-hand side and come down the left-hand side. And that little important block on the left-hand side is what the ALG is actually. It's just a little square block at the top. And it's really where data is swapped between the two protocols. But you've got to decode the full protocol, you've got to encode it, and it's going to be in the open at that point in time there. Okay. So scenario one, the forward ALG. Okay. Left-hand side, you've got a SEP1 meter, you've got a SEP1 HAN. And you've got SEP1 HAN devices. And the example there, I've just shown a PCT and an in-home display. And then if you add the application layer gateway, which converts between SEP1 to SEP2, you could add, on the top there, I've shown a ZigBee device and a ZigBee network. On the bottom side, it shows a Wi-Fi as an example. So in this case, we didn't need to upgrade the meter. We can still support the SEP1 HAN devices. We can support the SEP2 HAN devices on the right-hand side with the ALG. But because the function sets don't exist in the application layer gateway for electric vehicles and distributed energy resources, because the SEP1 meter doesn't support that, we have a limited set of functionality that we can support with the SEP2 devices. So for instance, electric vehicles would not be easily supported in this scenario. However, if we added into the application gateway a connection via the internet to a SEP2 server, the additional function sets could come down through the internet. And this way, you could support all SEP2 HAN devices at the same time as supporting SEP1 HAN devices. So here's a fully implementable HAN using a cloud server on the right and a SEP meter on the left. It brings along some issues because if you get both time and you get DR events and you get, for instance, pricing events from two sources, one from the right and one from the left, you're going to have to do some contention handling and some jiggery-pokery to make sure that the two devices at least operate in the same way, because you're going to have two sources of data if you're not careful. Although you could say that SEP2 on the right-hand side does not provide time, price, and DR. It only comes from the left-hand side, and the advanced function sets could come from the right. But here's a network that you could build, and all this needs is the application layer gateway and internet access. Scenario 2 is the reverse of what I've just talked about. Okay? You did build a SEP1 HAN, and you've just converted to a SEP2 meter. Okay? The meter suddenly jumps from the left-hand side to the right-hand side now, because now you've got a SEP2 meter. And this is called a reverse ALG, because now you're going to be making SEP2 data coming along from a SEP2 meter have to drive SEP1 devices. So it's a reverse ALG. Okay? That way you can support all your SEP1 HAN devices and you can support all your SEP2 HAN devices, providing that meter on the right-hand side could have been fully upgraded and it's not got a reduced function set. And again, that's the whole interface is the application layer gateway to do that, reverse ALG. Here's a sort of hybrid scenario. One that overcomes the problems with overlapping what we call events. So instead of on the left-hand side, the SEP1 meter now providing all the function sets, okay, maybe you only go to that left-hand side to get the energy out of the meter. The right-hand side provides all of the SEP2 data. It provides both pricing, time, DR events, and all the advanced function sets of SEP2. And all we use to connect to the left-hand side now is to get the metering information out of the meter. We could support both SEP1 and SEP2 devices, but here's an example where I say maybe the energy data is the only thing you get from the left-hand side. You don't have to, and this is a scenario probably where someone's deployed a SEP1 meter, some utilities, and they've not yet provisioned any SEP1 hand devices. Okay, it's just been there. No provision of SEP1 hand. Here you deliver an application layer gateway, you enable the cloud server, and now you can make fully operational a complete network, including the user getting his data from the SEP1 meter for his energy usage. So that's sort of a hybrid. So in summary, with the development of an ALG, it was possible to completely support the migration with the introduction of a ALG. It could be very cost effective because this could be a very high volume device. And this type of device we're talking about is similar to a router that you go out and buy it from and put it on your home network today. And in sort of volumes, people are paying $30 for that type of device. That's what it's costing in high volume today. It's probably, though, got a ZigBee interface in addition to the Wi-Fi that you would buy as a Wi-Fi router today. It could be automatically self-configurable for each scenario. It could be because of the advanced resource discovery in the SEP2 functionality. It could discover what resources are in the home area network, and it could configure itself to be a forward, a reverse, hybrid ALG without any user interaction from the user. So it makes a very easy installation. It could be customer deployable. Your alternative is to go out there, if you can't replace your SEP1 meter, is to go out there and replace it physically with a SEP2. That requires a truck roll. Any truck roll, any utility you ask today what the cost of a truck roll is, and it comes out into the hundreds of dollars, not the tens of dollars. A customer deployable $30 device that they get shipped to the home and installed is akin to the DSL modem days. I don't remember if in DSL days, DSL took off the moment that DSL modem became customer installable, because it was then very scalable about how you could increase the market. It's just deploy an ALG. In the DSL days, just deploy that DSL modem, ask the customer to plug it in, and he got service. Okay? And it's also fairly future-proofed. That device is very upgradable too, and very cheaply replaceable once you add an ALG. Because if you remember, I don't know how many DSL modems you've got through in your time, but in my time, I've got 3 or 4 old ones in my boxes. Each time you wanted to add new functionality, you shipped out a new ALG. And the cost is basically dispatching another $30 device, not going and installing another meter. So it's a very future-proofed deployment scenario, customer deployable. Okay. Questions and answers. Erfan's got to come around and drive the system again.
Yes. Thank you very much, Mike. And what I'm going to do is, as you all formulate your questions, I'm going to do a little bit of role-playing with Mike here and have him wear different hats. And then he has to present cases to me on how people would respond to different stimuli. Because this is very important. We're not dealing with so much of as a technology problem here as it is a social and behavioral problem. What we have is, in this country, an impression that smart grid has been implemented in a big way. And therefore, somehow, the momentum of that is driving us, even though we'd want to take it in a different direction, but the momentum seems to be going a certain way, and it's becoming a self-fulfilling prophecy. So here's a reality check. If we were to take all the smart appliances today that are installed that are using one of the legacy protocols, and I call them legacy now because they've been around for 2-3 years, or maybe 10 years, but they're legacy now, and compare those numbers with what we are projecting for the smart appliance population to be like in 5 years or 10 years, I would say that that number would dwarf compared to what the forecast is. So if you think about it, logic would say that we need to contain the current situation, create the appropriate ALGs as Mike is talking about, and then start focusing on what the future is bringing, because that modularity, that open standard will drive costs down. So the question I have to you is, if you were a regulator of a state that has already said, let's roll out smart meters, let's put the home area networks on with whatever is available today, and now you are releasing this 2.0 and this commercial product, what would you do as a regulator who has gone and spoken to utilities and told them to get rolling, and now this new thing has happened? So how would you create a constructive dialogue with the same utility if you were a regulator, so that you would encourage them and that they would not be pessimistic or scoff at you and have a constructive engagement with you?
Yeah, so I think the big mistake that we all made in the very beginning was trying to deploy the smart grid for the home area network via the smart meter. The smart meter is something that the utilities expect to write off over a 15 to 30-year period. And that 30-year period is pretty tough when you've got an ever-changing function sets, features, set of interfaces. Who knows what the next interface in the home is going to be? We have Wi-Fi today, and it's N. But you know there's another one coming tomorrow that's even faster. And every time you do that, you need to go out and replace it. So I'd like to see the encouragement of this gateway, so that we have a very quick and progressive way to enable this functionality out there. For instance, the users could upgrade their own gateways. That's never going to be a deployable situation. You're never going to be allowed to upgrade your own smart meter. So having a consumer device be part of the consumer network is much better than having a smart meter. So I think we've got to talk about consumers' devices being part of the smart grid. And I think that would enable a lot of innovation, because if we could freely drive that and also get the MSOs and the broadband providers, maybe they should be the one that should be enabling the ALG, because that could be part of the modem that they provided. It does not have to be a separate device. It could be provided by the broadband and provided as a service. Why not? The MSOs and the broadband operators are looking to get money for services, and this is a great way of them doing that, and they know how to provision in large quantities these types of services. So I'd say consumer devices is the way to do that. The gateway should be that, not the smart meter.
Okay, and now role number 2. You are an executive of a company and that has a board, and a year ago you went and asked them for money to do R&D for SEP1.x because you're making the firmware for it. Now, because 2.0 is available, you want to put some resources there. So what would you tell the board why you've had this sudden shift in your R&D priorities?
I think the market will actually dictate that, because look at the number of SEP1 devices and why the states didn't deploy SEP1. It was a non-standards compliant device, and I don't think if you look at it, SEP2 now is approved. It's a specification that's been thoroughly interoperability tested. It'll have a certification process that's been devised by the 3 main home plug Wi-Fi and ZigBee alliances altogether. So this is now a very much more industry-led driven protocol. And the answer is standards, standards, and standards. And this is going to ensure, I think, a lot more life in the product.
Great. Now you are an executive, let's say at a partner level of an integrator, like the company that is hosting us today in the seminar. For a long time, the trade rags have been saying, where's the money? Where's the money in this commercial, in this residential sector? Now all of a sudden we have this standards-based object model and this firmware that is being produced by a few players, and all these smart appliances are coming out. As a partner, in an integrator company, what would you say? How would you tell your fellow partners and the company as a whole to get behind this ball for customer prem integration, since for the longest time we've been hearing there's no money in it?
Yeah, good question. I don't really know the answer to that, other than this is going to be market driven. If the market's going to happen, it's going to be because the market decides to do something. And I've seen the participation in the SEP2 from the major players, and I think there is the backing to do that. So I believe it's going to happen, and so you just got to decide whether you're going to be in there as an early adopter or not. And to me, it makes sense that if you want to go out and be a major player, that you have to be an early adopter in this market. There is less, I would say, risk in SEP2 than there was in SEP1. If you're a SEP1, you probably got burnt, and you're asking yourself, I did SEP1, I put all that energy into it, and yet it went nowhere. I think the second time around, you might say, well, I don't want to be burnt twice. But I think the second time around, there's been so many lessons learned from the exercise, so much preparation has gone into this, so much interoperability has gone into this, that the risks are now really just a market risk. It's no longer a technology deployment risk.
Just to give you a little piece of anecdotal information, many of us are old enough to know that the original EV died an early death. And we learned many lessons from it, and most of it had to do with convenience. It was very difficult to maintain that vehicle and charge it. It was zero emissions, just like the EVs today. But in the last 25 to 30 years since that original one came out, there's been a lot of improvement in information systems. There's been a lot of improvement in the charging capability, and also in the distribution of these chargers around metropolitan areas, and now increasingly on highways along the way. The result has been that in the last survey done by Consumer Reports, they found that the Model S car sold more than the S-Class Mercedes, the high-end BMW, and the A8 series of Audi, by significant margins. I mean, it was like 4,350 or so Model S versus 3,000 something for Mercedes, 2,000 something for Beamer, and the Audi was under 2,000. What this is showing is that when you provide a good product and you provide the support, people will come and buy. So for those of you who have witnessed the challenges with SEP1.x implementation, it's a little bit of a self-fulfilling prophecy. Because it was highly siloed, because it was proprietary, didn't really allow for the Wi-Fi and the home plug and other alliances to get into this, it was somewhat limited. I have to give credit to the ZigBee Alliance. They did a great job of bringing in as many vendors as possible, but it was still in a closed environment, even though the stack was even provided. The specification was open. So it became a de facto standard, but not a de jure standard. And we need to move towards de jure standards if we're going to have mass deployment. All right, now I have another one before we get to the questions. And that is that how do you see the impact of SEP2.x on the kinds of things that I spoke about at the beginning, about hopefully one day being able to shape the demand for electricity so that it's much closer to the supply from renewable energy?
So there's a lot of thoughts gone into the function sets, but most of them align themselves to SEP1, except that it's been proven to be very easy to extend SEP2 to add new function sets. And as the target's going to be a moving target all the time, I believe if you deploy it in a gateway type of philosophy, it's SEP2.1, SEP2.3, so it'll be easy to deploy, easy to roll out. And so to enable that quickly, you need the gateway, I think. You need a protocol that's easily to upgrade and extend, which this has got. And but you're still going to need the utilities to deploy some of the functionality from the back office. And we haven't talked about this, but one of the important things about SEP2 was the alignment of the SIM to the back office SIM. The utilities got a structure of their data that now the home area network in SEP2 is very well aligned to. It should make deployment fairly simple from their point of view. So I think that's going to be one of the big drivers, personally, in that it's going to be easier to deploy this because there's very little translation to be done between the back office data that's being structured, the way it's structured, and the home area network. That's going to be a huge improvement. So I think that's going to drive it really, from the utility point of view.
For some of you who may not have the background on this detail on object models, a key thing here is that if this data is taken out from home area networks and without massaging it too much, is available to utilities and aggregators in the common information model, not only is this good from a data privacy perspective because there will now be a reservoir and a secure place for this data, but also for doing the analytics on this data in order to get actionable intelligence out of it and create better marketing programs and more incentives for consumers to get more involved. It's something that will feed on itself. So having the right format for this data is critical from a business reporting perspective. And then from the other side, and I'm very happy to see that the SunSpec Alliance is doing this with photovoltaics, with inverters, is that they're coming in through the 61850 route and creating mapping with smart energy profile. So now we will have the ability to control as field equipment from a utility perspective, and then from a reporting perspective via SIM. So thank you so much, Mike. And now at this point, we will take some of these questions that have been gathering. The whole purpose of this role-playing was to be a little controversial and make you think and start asking questions or make comments. And I see that we have succeeded because a whole bunch of things have come up. So we'll spend the remainder of our presentation going through some of these questions.
Any from the room?
We'll do that. I got a couple.
All right, so let's start. Chris, why don't you ask your question if you could come a little closer?
Come a few bars and I'll fake it. You talked about one of the issues with meters and upgrading being that the meters didn't have the memory to support the SEP2 protocol as opposed to the SEP1. And so I have a kind of a 2- or 3-part question that deals with the penetration of SEP2 HANs into the market versus the penetration of SEP1 capable meters versus SEP2 capable meters into the market. How much of a disparity there is there?
So in PAP 18, a calculation was done about how many meters couldn't be upgraded. So there's 120 million households, approximately, when you look at different surveys, between 45 and 55 million have been deployed today, of which 17 million are probably not upgradable, 17.
Okay.
They were deployed many years ago before anybody had a view of even what SEP2 was even going to be on the cards. So we have a problem with 17. Unfortunately, the 17 represents today a good proportion of the meters deployed, but in the long term, it's still probably 15% of the total deployment.
Okay.
So it's an issue today, but it shouldn't represent an issue in the future.
Okay.
That's my view.
And is the ALG a solution to all 17 million of those, or are some of them so far out of date that they're simply going to have to be replaced?
No, I think the ALG is a solution to all of them. And by the way, I believe it's a solution to the deployment of the home area network, full stop. I don't think we need a consumer device in the consumer network to be the thing that gets upgraded for the smart grid in the home. The smart meter is a device that's going to stay for 30 years, and no consumer device lasts more than 4 to 5 years in our market today.
Yeah.
Not because it's broken, it's because we make so much progress in adding functionality that we want to upgrade it. How many DSL modems have you had at home? I've had 4 or 5, and each time
I'm a techno peasant.
well, you probably then still at 12 megabits or probably 4 megabits.
We have to think, just like we did not discover the photoelectric effect because we kept thinking there was an ether, and otherwise Maxwell would have figured out the photoelectric effect for years ago. We have the same issue where we keep thinking that the smart meter has to remain engaged with the home area network. There is no such lockdown. With the advent of the next energy detector, the TED, and technologies like that can actually measure energy usage from disturbance signals on the wire, I can see in not so distant a future a very inexpensive device that you would plug into the phases of the house that would report that information to such an ALG and completely remove the need for having energy reads from a meter. What does that mean? That means that the smart meter can then do remote connect, disconnect, automated meter reading, and just publish DR signals if it needs to through the meter.
Yes, but aren't you then asking the utility to maintain 2 separate networks, one of which processes data back and forth to the smart meter and is basically just smart meter operations, and then another one that is customer operations delivery mode where you're using Wi-Fi or other mobile devices or whatever to deliver meter usage data, which you then have to combine perhaps in the gateway with your home area network information to be able to get an intelligent display of what the heck's going on in my house?
You ask a very good question, and the answer, I was not trying to be blunt and candid about it, but now you're obliging me to, so I am going to do that. This is my personal opinion. I think that the whole growth of society post-industrial revolution has been because of division of labor and the access to capital. We'll put the capital access aside and talk about division of labor. If all the parties in the electric sector were to do their jobs well, we will see such a division of labor going forward that your issue will become a non-issue.
I agree. However, that is a huge caveat in that first phrase that you put out there.
Agreed. And this is why we find in our midst today on the call many regulatory bodies that are listening very intently to this conversation, because in this conversation are ideas for the future. We cannot keep looking back at the last 150 years of electricity delivery to talk about the future. Granted, electrons using force will keep moving motors just like they've done the last 100 years. Physics is not going to change. But the way we perceive of electricity as a commodity is going to change because of the advent of this technology. And I believe that utilities are well served by staying focused on what they do well, which is deliver electricity reliably. And we will see the coming of businesses that will work in conjunction with utilities to provide a lot of these value-added services. And that, I think, and with the proper regulatory framework that doesn't say to a utility, if you produce fewer kilowatt hours, you're going to lose. No, that's not going to work. So something's got to change there that allows them to produce less and still be profitable. All right, so...
and by the way, the AMI network was built really to do meter reading, and that's really all it's capable of doing. And so to provide all these advanced features that we talk about through the internet seems the only way forward to me, unless you go and rebuild the AMI network again.
And
I agree with that, absolutely.
And it is ironic that that limited scope has been a huge barrier for munis and co-ops to make the case for AMI because they've had AMR for so long. That the additional value is not so clear to them. So I think that going forward, if the meter data can be somehow fed back to the SCADA system to help reduce line losses and see what the benefit. Today's SCADA systems are not doing a very good job of that. But the next generation of SCADA systems, the more advanced applications that we're seeing in the future, if there can be a loop back, and today even the way the data is collected is not properly architected, because that data is going to a meter data management system, which is in a different jurisdiction than the SCADA part. But let's say there was some capability at a substation to map this data onto the SCADA system. What it can do is help in the planning models. Because today, a lot of the planning models that decide how much energy goes on the various segments is based on a probabilistic model, usually from data the day before, and then they project to see on a forecast based on yesterday, and then they think what it will be. If we had 15-minute interval data collected, we could use that macro value to turn a probabilistic model into an empirical model. And that conversion, and there's a very good report in EPRI, and I've mentioned this before, it's 1018984. And Nokam Markushevich does a great job talking about these future applications, the DA applications, where meter data can be used. If we were to do that and monetize that for the utilities in terms of reduced line losses, then I can see a very good business case for smart meters. But just on DR and those kinds of things alone, I think it will be hard for some munis and co-ops especially. IOUs maybe get away with it because of the large service territories. But munis and co-ops are having a very difficult time. Okay, we have many questions and we have limited time. So let us continue.
So I can answer Slav's first question.
Yes.
Does ALG provide MAC5 bridging, or is it strictly application layer device? The answer is it provides MAC layer. It provides bridging as well. It's an all-in-one device. It'll effectively do bridging as well as being the ALG functionality. It's built into it. Chris's question: under the three ALG scenarios presented, the utility wirelessly transmits energy data to the gateway. Assuming yes, how do you convince the utility to provide access to the media data on a large scale considering privacy issues? That link between the ALG and the smart meter is an encrypted SEP1, and to the user it's an encrypted SEP2 device. So the data should comply with any of the privacy requirements because it's wholly encrypted by the user in the user space. So only the user will have access to the data, and that should not be a problem.
Yeah, and there is actually a FERC ruling on this about the handling of large amounts of customer data, especially when you know from a GIS perspective where that data is coming from, because you can use it to hedge your bets in the energy market. So you're not supposed to use it unless you make it publicly available so everyone has that. Otherwise, you have an unfair advantage in the market. So those aggregators are well advised not to use it in that way because you don't want FERC to get upset.
Next question was from Gary Sorkin. Hi, Gary. My question: how do you see the acceptance of SEP2 in Europe? Isn't 6-low-pan handler the pack there now with IPv6? Well, ZigBee IP uses 6-low-pan, and the IPv6 is the lower layer of protocol for SEP2. So I don't. By the way, the use of smart grid hands in Europe is yet not taken off, except for maybe electric vehicles. So I think they have still not had the full debate about smart grid hands, so I think you can defer that another few years. By the way, the UK was going to deploy a hand, but I've seen that as of a few days ago. It says that's delayed another 4 years to 2020, or 2019. It was 2015, and now it's 2019. So I think the debate about what should we use in Europe is still open question for me.
Yeah, and there are some very direct lifestyle issues involved in Europe that is making it difficult to have hand deployment. One of them, of course, is the weather. That HVAC, which is the primary driver here in the US, what we want to do by clipping the peak, a lot of Europe doesn't have as big an HVAC problem as we do in our hot regions. And then in the winter, whereas in the East Coast we have a lot of electric water heaters that could drive up consumption, in Europe still they use a lot of chemical-based processes for heating up water. So this is why they haven't been able to make the case, but for EVs, especially because of the clustering problem, we need to control that to not have to force the transformers to be upgraded all the time.
And it says now with IPv6 isn't the Internet of Things going ahead of CSEP? Well, SEP2 is actually just a prime example of Internet of Things. It's an Internet-enabled protocol that's defined in a data structure that's for energy. So I see it as an Internet of Things. From Paul, even if a meter has a single 802.15.0 radio, couldn't network MAC layer determine whether a SEP2 or SEP1 device is communicating to it and then perform the translation from the application layer above? That seems feasible, hence the smart meter could do the translation between the two profiles itself. This would make go down a little bit, fan please. This would make a separate ALG piece of equipment in the home redundant. The frame structure for SEP1 and SEP2 is not the same, and there's a lot of people who's looked at that. And in the scenario for a meter, I don't believe it's possible to make the radio work in both a SEP2 and a SEP1 mode. The prime problem starts at the very MAC layer. The MAC layer uses non-encrypted 802.15.4 MAC layer, 2003 MAC layer for SEP1, and on SEP2 it uses a AES-128 MAC layer for SEP2, so they're incompatible with each other. And you want the EPRI report number again? Are you going to post that?
That's 1018984. And Nokum Markushevich was the contractor, and this was done about 2.5, 3 years ago. Yes, we have some more questions that we're going to answer here. The plan, Erfan, with SE is to use BPL, for example, rather than wireless. This will be the case in home and buildings. Yes, very much so, because you want that platform independence.
Yeah, and I didn't mean to just put ZigBee and Wi-Fi. I just ran out of space on my slides.
Yeah.
In fact, if you go back to my block diagram, I did show, it's not actually BPL, but it's actually home plug GP. I did put home plug GP on my slides as an application protocol. And it'd be easy to add that into the application layer gateway.
Yeah, actually you have to defer to Mike. He is in the guts of these protocols to the point where he can see the similarities in protocols. And if you look at home plug real close, and you look at Ethernet real close, all you find really is the difference in the physical media on which the signal runs. It pretty much follows the Ethernet. So when he says Wi-Fi, he's thinking home plug in a different physical state.
Yes.
All right. So the next question is, plan for SEP2.0 over a wired or fiber network, not lock into wire. I guess that's connected, right? Those 2 points are pretty much similar. There are other questions here too. Says William Miller says, I'm concerned that REST is being used and web services which has a security vulnerability.
The way the data is encrypted, I don't believe there's a security vulnerability using REST. The data that's used is encrypted using ECC. So although REST is being used, the data is encoded, so it has to be decrypted first before it makes any sense.
I think that when William Miller talks about security, he's not just talking about it from an encryption perspective. He's talking about it like in terms of making systems vulnerable to compromise. Not just from, because yes, if the data is encrypted and the key is very complicated, then it's very hard. The probability of breaking that is very hard. But if there are vulnerabilities on the stack that can be approached.
Exploited.
Yes, that's what William is talking about.
Yeah. I don't know how to answer that one. I'm not a security expert.
So, William, the answer to that comes in the testing and certification part, because that's when you do components-based testing to seek vulnerabilities. And one thing that I keep reminding people, because I was involved when the whole smart grid interoperability thing started 4 years ago. So it's almost like a parent that knows that the abilities of its kids. So there's some strengths and there's some weaknesses. One of the weaknesses of use case methodology is that it fails to address the bottoms-up approach. And that is done in labs by testing. So when you challenge like this and say REST and it's not secure, web service is not secure, write a script, run it in the lab, show how you compromise the system, and write about it. That's the best way. We are living in a free country. We need to have this information out. What I find increasingly in forums is anecdotal evidence is presented. And it's very difficult to challenge it because the other side doesn't have the empirical evidence to support the counterpoint. But I would entertain this, and I would ask all of you to entertain this, is in your respective areas, if you think that you are seeing some issue, create a little project, demonstrate it, and document it, and then put it in the body of knowledge that we have in the industry.
Okay, the SEP2 security expert, Robert Craigie, has just posted a response to data is protected under HTTPS, not at the application layer. Vulnerabilities in web services are at the application layer. That's his answer.
Right. Okay, very good. And thank you, Robert.
Question from George.
Yes.
Or was there one before that?
We addressed that question before?
No, I don't think so. There's another one before George.
No, you mean below or above?
Above.
No, I'm going there. I'm going in the reverse direction.
So is SEP2 acceptable in the EU, or are there any other standards under development like the open meter? So there is one for electric vehicles being developed in Europe called ISO IEC 15118. And so it has several commonalities between SEP and 15118 in that they use IPv6, they use XML or EXI in that case, but they don't use, they actually invented a V2G type of protocol, or a packet protocol.
Yeah, just quick technical note. You see the interplay between IPv6 and 6LoWPAN. This may be second nature to many of you on the call, but for those of you who are not well versed in this area, essentially 6LoWPAN is a version of IPv6, but it uses a smaller header, and these types of abridged versions are used in mesh type protocols that are low power, narrow bandwidth. Whereas in
very short packets.
Very short packets, yeah. And then when you have the longer MTUs like Wi-Fi, then you just use the full-blown IPv6.
Yeah, otherwise, if you try to put an IPv6 header in a very short packet, you get no data space.
Yeah.
And so they have to compress the packet header.
Yeah.
If getting another modem in a home is too difficult for some customers, could there be a feasibility where the actual customer appliance in home, which has the ALG processor to receive and transmit the commands? Yeah, absolutely. But you have to be careful that if you have 5 appliances, you don't want to end up with 5 ALGs because a home only needs 1 ALG. But I think if another device was to support an ALG, my view of where an ALG should be is actually in the broadband modem. Broadband modems now come with Wi-Fi and a router in them and everything, and I think it's an opportunity for the broadband providers to provide a service. And I think effectively the ALG could be built into the broadband modem. And I think some of the operators are looking at that opportunity right now.
Yeah. So one possibility is that the modem be spared, but the router that comes in the house, the Netgear or the Belkin or the Cisco type router, which today only handles up to layer 3, could go all the way up to layer 7 and have that, because now with ARM processing and all this capability, you can have very small form factors.
Yeah, you could. But I'm thinking it's the modem and the routers combined into one box.
Oh, that would be super.
It's called a gateway. I mean, AT&T deploy a U-burst gateway, and that actually has got a lot of functionality in it. I believe it would only require a software upgrade to support SEP2 over Wi-Fi, for instance.
They have them specially made for VoIP, so
yeah.
there's no reason not to.
Yeah.
Bottom line is that SEP2.0 is opening up possibilities. So with that, we'll move forward.
Yes.
We don't want to make architectural prescriptions on the educational series because we want innovation and we want it at the pace of value, right? Isn't that what they call it? Development at the speed of value. All right. Let's look at the next question here. The products need to be technology agnostic and protocol independent, and I think we're accomplishing that with 2.0 and the services that are supported by it. And then Mike Shea, go ahead.
Okay, when a HAN in a home stopped working, e.g. a smart refrigerator stops defrosting over a month period, who could the less technically savvy homeowner call to resolve the issue? Would PG&E, for example, answer a call as such to help debug the HAN issue? The answer is, it won't be PG&E that's going to answer that call.
Really?
And by the way, how SEP2 works is actually, PG&E is never going to tell the device itself what to do. What it's going to do is going to make information available in what's called the ESI functionality, acts as a server of information. The refrigerator is going to go and talk to PG&E and find out what program, if any, is available and decide whether it's going to participate and join it. It will down to the refrigerator to decide whether it participates and whether it obeys it, and not down to, it's not going to be an instruction from PG&E to tell your refrigerator to go into a cycle, any form of cycle. It's up to the refrigerator to go and get the information and decide whether it wants to participate or not. This is a question from Kevin. In order to facilitate more customer adoption, what would it take to get customers to want this ALG? Should utilities provide thermostats or in-home display to customers? Who drives this demand? How to prevent the market flop of SEP2? Thanks. So I think there has to be some incentive for homeowners to do this, and I don't know what it's going to take, but I know some people are thinking some way of incentivizing the user to participate in that by rewarding them for doing so, which obviously, if you're going to respond to a demand response, you're actually saving the utility some money. And the cost of energy production at peak times is much more costly than it costs. They make a loss on that. So in other words, they should be able to, if they're going to reduce their losses at that peak times, they should pass on that reward to the customer somehow. How they incentivize a customer is going to be down to the utility, but I would like to see the ways that some California utilities do it. They give you a voucher, or they give you a rebate scheme for going and purchasing a device. My wife just bought a new washing machine, and she got a $200 rebate from PG&E for buying an energy efficiency one. And that wasn't to save much money, by the way. If you looked on the energy efficiency chart, it said it saved $23 a year from an older dishwasher. So it saved $23. Yet I got a $200 rebate back from PG&E for doing so. A thermostat could save a lot more than that, so I can't see why there can't be a rebate or even a voucher from PG&E to pay for an installed thermostat for that. In fact, there are programs today from PG&E where they will come and install your thermostat on a radio-based one, on a SEP2-enabled thermostat, and they'll do that free of charge. So I think there will have to be incentives to do it, because I don't think customers necessarily will want to save money on their own. They'll have to be incentivized to save money. How that incentive comes, it's going to be down to the utilities. But
right.
Everybody gets motivated a different way.
So there are a couple of things where going forward we'll have to do things a little differently. One is, how long does it take for pricing for electricity to change? We're going to have much shorter cycles than this 3-year kind of time frame, because we are going to see rapid changes in the marginal cost of electricity coming from these types of renewables when they become a big percentage of the overall energy mix because of all the special things that we'll have to do to the grid to stabilize it. It's not just about the solar farm or the wind farm. There are other costs that go into the infrastructure. So if the cost of electricity does not reflect what it takes the utility to make it, we are creating a cross-subsidization plan. And there is no scalability in that. So there are some very creative pricing schemes that are being presented. Ed Cazalet and others talk about transactive energy as a way to curb some of the problems of the big difference between low price and high price. But ultimately, the regulatory bodies have to work very closely with the producers of electricity so that they create a program for pricing that reflects the pricing for the utilities. Today, there's a lot of cross-subsidization going on. And I feel that that's not scalable as we move to renewable energy as a bigger mix of the overall. So once the pricing reflects, then there'll be an economic incentive, not only for the utility to curb those peaks because they'll get benefit from the regulatory policy, but customers also are going to save a lot more than just the incentive that the utility will give them or a manufacturer. If there's 5-to-1 price difference or 6-to-1 price difference, people will behave differently and there will be much more adoption. Today, the ROI on these boxes is going to be long. So it's all connected to each other, but ultimately, and this is why I'm so glad regulatory bodies are on this call, because a lot of the future really belongs to them and how innovative, creative they are, and how they engage with aggregators and utilities and vendors to create an environment conducive for renewable energy integration. All right.
So
there was a correction from Jeff Mulligan.
Yeah, Jeff Mulligan, who is the author of 6-low pan.
Yes.
So I know correctly what 6-low pan is, and thank you for letting the audience know. It's just an adaptation layer, just allows efficient carrying of IPv6 in a shorter frame that 15.4 does. Thanks, Jeff.
Yes. Yeah, we didn't want to imply there was a completely different version, but the header is not compressed, but
the adaptation layer is different.
Yes. Okay. Next question. We
just
have to move up.
Kevin's.
Did we do this one?
Yes.
All right. Next question is, the smart thing is to put SEP in to energy savings devices, but do not focus on smart metering. This is a huge opportunity that companies around the world are supply energy systems. HomePlug is a good type of example.
Yeah, I totally agree.
All right, moving along. Mike Shea says, have the carriers like Comcast shown interest in supporting or even deploying LG? We've been talking about that, but what's the verdict up to now?
I'm under NDA.
He's under NDA. So he's pleading the fifth. All right. Mike Shea says, would the smart appliances be brought to the market with SEP2.0 functionality? Well, that's just a matter of when they're being released.
Yes, and many ways of how they're viewing how to make smart appliances is using the CEA adapter, which allows you to ship a standard machine and then plug in a CEA adapter with the right fiber that you want to supply, and then it turns it into a SEP2 or a smart appliance. So it's the CEA adapter.
Correct. And the key thing, and we didn't talk too much about the adapter because we've had other sessions where we've spoken about the standardized interface. I think the standardized interface can play a very critical role as we transition and put the intelligence embedded in appliances in the future. And it can very quickly, as Mike was showing, create a SEP2.0 environment all the way up to the front door of the appliance. Now, inside the appliance, that CEA 245 will convert an SEP command into some electromechanical command, which will take care of some primitive function in the appliance. We don't need to worry about it. The vendor deals with that. As long as it creates the necessary saving, what difference does it make how it was finally accomplished, as long as the HAN is standard.
So the question from Michael, would a utility company that's deployed SEP1 meters continue to deploy SEP1 meters or to start to deploy SEP2 meters? I think that's totally up to the choice of their deployment scenarios. I think with the ALG, it allows you to continue if you want to support extra functionality over the internet. You have to decide if the internet is available for all your consumers to use. So built-up urban areas which have a high degree of population that uses broadband can get the extra functionality from the internet. However, if you have a large proportion of your population that can't get internet or doesn't have internet, then if you wanted to support some of the advanced function sets, you would have to really start deploying SEP2 meters. So it's a difficult question to answer because you've got to look at your population.
Following the model of X.25 and IP and IPX and IP, I would say that this is the time when the SEP1.x meter deployment's curve should be concave downwards, and the curve for SEP2.0 should be concave upwards. Next, Roger Levy.
So does ALG support of SEP1 and SEP2 simultaneously require gateway binding to the meter? No, you only need to bind to, if you're a SEP1 meter, you only need to bind the SEP1 portion of the gateway to the SEP1 meter. The SEP2 meter portion of it is bound to your hand devices and is actually, because the gateway resides in the consumer premise, can be under the total control of the consumer. So the answer there is yes and yes, if you've got a SEP1 and a SEP2 meter.
I have to give credit to the California Public Utility Commission and especially to Alok and his team. They've done a remarkable job of creating very nice diagrams of the different types of home area networks that are possible that are very much in alignment with the way Mike described it with utility-centric, customer-centric, and hybrid models. So kudos to CPUC for doing a great job visualizing these. An already existing AMI hand system operating at RF mesh connected to a gateway router in home that is not designed for SEP1 or SEP2, can it be translated to SEP in an easy way? If yes, what are the steps to be followed?
You can always translate. It just depends on what level. If your AMI network is IP, you can have an IP hand network that's mesh as well. So it really depends on your AMI SEP network. But basically, if you're not an IP network, you're going to have to take all the data to the data layer, the very top layer 7 before you translate it. If you're an IP, you may be able to do the translation at lower levels. So the answer to your question is depends on your AMI network, but you always translate. It's software. It's only software, they say.
All right. Audio just returned. SEP2.0 installed where a customer does not have IP. Won't the limiting factor be the meter communication? Networks still not have capability to support EV or other data retrieval functions. So we addressed that. We said so.
Yeah.
I've lost audio status shows connecting for a while. Any suggestions? I think that was addressed. Please comment on the fact that 802.15.4 will become obsolete later this year and replaced with 802.15.4U.
I don't believe it becomes out of date. It may become deprecated, but it won't become obsolete.
Isn't this with the increased metrics for performance and things like that?
I don't know what U is.
Okay. We will.
I'll be interested in follow up with that.
Yeah.
William, you can contact me.
And anyone who volunteers on the 802.15.4 working group, if they're still on the call, can easily put a comment in chat and address this issue. Yep. So I guess that means yes. All right. So I think, did we do this question?
No, Hank. In scenario 1 with SEP2 Cloud Server, where do the hand client devices host their SEP2 resources, the cloud, the ALG, or elsewhere? With SEP2, with function set assignments, they can actually point to the cloud or to the ALG. So it's really down to where you want to host them. They can be hosted in the gateway, or they can be hosted in the cloud. And really it's down to the to where they're pointing to by the function set assignment, and that can be defined by the utility. So that's to answer Hank. If you understand, if you want me to explain function set assignments to you, Hank, just give me a call.
So we have a little bit of time left, and what I wanted to do was just put this presentation in perspective here, just a couple minutes, and then we'll have some closing remarks from Mike. Key thing here is that we're not suggesting that this is the cure-all for demand response or the cure-all for deploying smart appliances. What this is a disruptive technology. When you bring in IP into the house and you create an object model that is vendor agnostic because an alliance of many, many people brought it together, and it has simplicity on the one hand, and at the same time sophistication on the other hand to deal with the different attributes of appliances that you want to control. This is a disruptive technology. Now, it will find its home, no pun intended, in homes. But the key thing for all of you as a community should be to test its various aspects that you are concerned about. And instead of just raising a finger and saying, this is not going to work, or this is going to be unsafe, or this will not happen, demonstrate it in empirical tests. It's very, very important. It will go, just like we say a picture is worth 1,000 words, I don't know how many pictures a test is worth. And that's key. And we are going now into that phase. Because to turn this invention into an innovation to have mass appeal, the testing and certification part is critical. And security and data integration and big data management and analytics, all of these have to be enabled in order for this to go from invention to innovation. So integrators like IBM and others need to be on the back end in a big way and make as much hay out of this as possible from the data. The vendors who are making appliances should try to think, how can we take our current offering that's out there and make it smart as quickly as possible? And make sure in the R&D plan that there is the possibility of putting the smarts on the appliance itself, native. And then for utilities to start thinking of new business models for pricing that will incent customers to participate more. Aggregators need to get involved in this because there's so many services a utility just is not set up to provide. They can in partnership with them. So you see, everyone has a role. The consumer advocates like the Turn Group and these people need to be involved in a positive way. Tell us what is wrong based on focus groups and surveys, and let's address those issues. What I find in our industry is there are a lot of bright people. There's no shortage. Well, what the challenge is, they don't work together. A lot of times it reminds me of a third world country, the way we operate in our energy sector. And so part of my emphasis in the educational series is let's come together. Bring up your issues. And I'm really glad people like William Miller bring up these issues because it forces other people to start thinking what kinds of tests to do. So we're not saying this is an answer for everything. We're saying it's a major disruptive step forward, and this will open up new markets. And a lot of Mike's argument is about opening new markets. So Mike, do you have some final comments before we wrap it up?
Well,
is there more questions?
No, well, William was trying to state what the U was and whether it replaces that. I believe that's being used, I think that's been defined for use on the AMI side, but it does not matter. SEP2 doesn't define what ZigBee protocol or what Wi-Fi should be. But SEP2 will run over anything that uses IP. You could run it over Bluetooth. You could run it over DECT if it supported IP. So it's got nothing really to do with the lower layers. It's really independent of the lower layers. So if someone wants to go out there and say, I want to use a different 802.15.4 PHY, there's nothing that precludes that in the SEP2 spec. That's the good news.
Any final comments on the market or the protocol or what you would like to see happen next? What's your wish?
The good news is that The 1.0 version of the SEP2 spec now is out there and it's in complete public domain. Anybody can download it. Anybody can now start building to it. They have the latest spec. Up to now, you've had to be a ZigBee participant to view the latest version. Now the public version and the ZigBee version is the same version, and there's nothing precluding it. It's going to move out of ZigBee probably to IEEE and become a complete standardized. ZigBee was just a custodian of the spec during development, and as you know, Wi-Fi and HomeFlow have contributed to it. So it's now going to move out of ZigBee out into the complete open. So it's a complete open for anybody to start looking and deploying it. So the opportunity is there for anybody to develop a product based around that. I don't think there's a shortage of ideas. I've seen some really pretty creative, because SEP2 doesn't define what you do with it. It defines how you do it. It doesn't define how you do it, really. What you can do is put any like application on top of this, and you'll get based on the information you can get from the utilities. So I think it's just creative juices that are just going to flow now. It's a good framework for everybody to use.
Chris, do you have any comments?
No, not really.
Okay. One thing that is just an interesting coincidence is that for dealing with some of the more advanced features for electric vehicles, it would require a full service SEP2.0 implementation, and that's why you recommended the internet way, maybe if the meter cannot handle 2.0?
Well, not the full service. There's some additional function sets that are added for electric vehicles into SEP2. One of them is called flow reservation. Flow reservation is only available as a SEP2 function set today, not as available as a SEP1.
But you also made the point that those meters that might be able to be migrated from 1.x to 2.0 may not be that full.
Yes, so they have to pick.
So
they have to pick,
that's what I'm referring to.
They have to pick and choose which function sets.
Yes.
So, for instance, depending on the memory available, you still may be able to implement flow reservation, but you may not be able to implement DER.
Right.
DER is distributed energy resources. It's a big function set. So it depends on your memory available about what function sets you can deploy. So you really can't be pick and choose it. A utility will have to deploy to do one or the other, and if not, go to full 2.0.
The nice thing is that the demographics that can afford electric vehicles can also afford an internet connection.
Yes.
And that is so remarkable, because when you buy a $70,000 Tesla S model, then you can afford that $16 or $30. It'll go up.
No, it'll come down.
You think so?
The electric vehicles will come down.
I hope so. That's a lot of batteries.
That's a lot of batteries, but if you look at the Chevy Volt or something like this, they've already come down. They're not nearly $70,000 vehicles.
Yeah.
It's not a ton cheaper, but it's still cheaper.
So we're enjoying some economies of scale.
So a study showed the other day that 5% of the people are going to choose a vehicle, a new replacement vehicle, in the next 12 months. You know what the percentage we're going to consider electric vehicle?
Half.
No, 5%. I thought that was big. But half would be huge. But
in Berkeley.
5% nationwide.
Yeah.
People are who are looking to purchase a vehicle in the next 12 months. 5% of the people are going to consider electric vehicle.
That is actually a very high number, and the reason is because how few years Americans keep vehicles. So if that number is multiplied with each cycle, you're going to see a lot of electric vehicles. My only concern is that is DMV connected to the utilities, and is it transferring that information the moment a car is registered so that the utility can upgrade their transformer on the street where that person is living?
You know the answer to that one. The answer is no.
Yeah, and that is what my concern is, that with clustering and with deep penetration that we need to address that issue.
My personal opinion is that if you want to increase the number of electric vehicles that are being purchased, you have to make the public better aware of the infrastructure for charging those things that's not their home.
Yes.
For example, I can't drive one to this building from my home. There is no place to charge it, and there's not enough range to get it back home.
Shame on IBM.
Well, unfortunately, IBM doesn't own the building, so we were absolved from that particular.
Pay the rent for the building.
Yeah, so there is a little bit of correction there that needs to occur, and with societal pressure we will see that, and we're seeing that with water fountains in public places. We see it with restrooms. we are hoping that we'll see it with charging stations also. So I wanted to end this on a positive note. I think that what Mike has shared will force us to think about home area networks in a new way. We went down this path with a highly siloed proprietary way, and we got disillusioned, and there was a quiet period, and we went into the trough. Now we're going into what we call the plateau of productivity, if you want to follow the Gartner hype cycle. And so with IP and with all the modularity that Mike has discussed. The other thing is that there is no one way to solve this problem. There will be multiple ways, and hence the architectures. The other thing is that there is enough action for multiple entities, the chip manufacturers, the appliance makers, the aggregators, the utilities, everyone, integrators, everyone has a role to play in this new model. And it's not a luxury, it's not a privilege, it is an absolute necessity going forward, given where we are headed with renewable energy and how much we expect it to be a part of the overall energy mix. We will not have the luxury of nuclear plants and coal plants sitting on the side waiting to make up for the difference. If we lose that solar or wind, we better turn on some DR quick to try to shape that electricity profile. Our next seminar is going to be on May 28th, and it will be hosted by TUV Rhineland in Pleasanton, California. They're a big testing and certification lab. They do a variety of verticals, but they are also for Wi-Fi and for ZigBee. They do testing, and they have RF chambers and everything. So we're very, very happy that they'll host us. And Chris Villarreal, our senior analyst in cybersecurity and other matters at CPUC, is going to be presenting on their new report on cybersecurity. Cool. So we hope that you will all participate and ask engaging questions. As you know, cybersecurity is the Achilles heel of smart grid. If this information gets in the wrong hands and it affects the functions of the grid, the blowback can be huge, and we can't have that. So with that, any final thing? Okay, we're good. At this point, I will end this presentation and the recording, and everyone enjoy your day, and we will meet in 2 weeks. Thank you.